Hello friend, welcome to my channel GATE and ESE aspirants. In this video, we will discuss about GATE and ESE previous year question on buoyancy and flotation. Now first question, for a floating body, buoyant force act at the option A, centroid of the floating body, option B, center of gravity of the body, option C, centroid of the fluid vertically below the body, option D, centroid of the displaced fluid. Correct answer is option D. Because in the situation of fluid statics, the net upward buoyancy force is equal to the magnitude of the weight of fluid displaced by the body. The center of buoyancy is an object is the centroid of the displaced volume of the fluid. Question second. For a completely submerged body with a center of gravity G and a center of buoyancy B, the condition of stability will be option A, G is located below B, option B, G is located above B, option C, G and B are coincide, option D, independent of location of G and B. So correct option is A. Here body in a liquid is said to be stable. When a small displacement, it returns to its original position. For stability of completely submerged body, the center of gravity G is below the center of buoyancy B. Now comes to question number third. For the stability of a floating body under the influence of gravity alone, which of the following is true? Option A. Metacentre should be below center of gravity. Option B. Metacentre should be above center of gravity. Option C. Metacentre and center of gravity must lies on the horizontal line. Option D. Metacentre and center of gravity must lies on the same vertical line. So correct answer is option B. For a stable floating body, metacentre should be above center of gravity. For unstable floating body, metacentre should be below center of gravity, and for a neutral equilibrium, both metacentre and center of gravity must coincide. Question number 4. For the stability of floating body, option A, center of buoyancy must coincide the center of gravity. Option B, center of buoyancy must be above center of gravity. Option C, center of gravity must be above the center of buoyancy. Option D, metacentre must be above the center of gravity. So correct answer is option D. Here condition of stable equilibrium for a floating body in terms of metacentric height. So stable equilibrium, so Gm must be greater than 0. M is above G if metacentre height is positive. For neutral equilibrium, Gm is equal to 0. Here M is coincide with G. For unstable equilibrium, Gm is less than 0. It means M is below G. Question number 5. Consider a frictionless, massless and leak-proof plug blocking a rectangular hole of dimension 2r into L at the bottom of an open tank as shown in the figure. The head of plug has the shape of semi-cylinder of radius r. The tank is filled with liquid of density ρ up to the tip of the plug. The gravitational acceleration is g. Neglect the effect of atmospheric pressure. Option A, 2 rho r square gl 1 minus pi by 4. Option B, 2 rho r square gl 1 plus pi by 4. Option C, pi r square rho gl. Option D, pi by 2 rho r gl. So correct answer is option A. Here F is the vertical hydrostatic force. F is equal to say rho gv. V is the volume of fluid above the curved surface. So F is equal to say rho gv. So volume of the cuboid minus volume of the hemisphere. So volume of cuboid is 2r into L, and volume of hemisphere is pi r square by 2 into L. So total volume is V is equal to say 2r square L 1 minus pi by 4. Now multiply with rho g, we get force. So F is equal to say rho g into 2r square L 1 minus pi by 4. So F is equal to say 2 rho r square gl 1 minus pi by 4. For bodies in flotation to be in stable equilibrium, the necessary and sufficient condition is that the center of gravity is located below the option A, located between the metacentre. Option B, located under the metacentre. Option C, located below the metacentre. Option D, metacentre. So correct The answer is option C, located below the metacentre for stable equilibrium. Question 7. A spherical balloon with a diameter of 10 meter, as shown in the figure below, is used to advertisement. The balloon is filled with helium at ambient condition of 15 degree and 100 kilopascal. Assume no disturbance due to wind. The maximum allowable weight in Newton of the balloon, material and rope required to avoid the fall of the balloon. It is one of the toughest question of GATE, so please solve it. Here solution for this, we need a free body diagram as shown here. So diameter of balloon D is 10 meter. Gas constant of helium is 2.08 kilojoule per kg Kelvin. Temperature is 15 degree, which is 288 Kelvin. Pressure is 100 kilopascal. Gas constant for air is 0.289 kilojoule per kg Kelvin. F1 is the weight of helium gas in the balloon. F2 is the maximum allowable weight. Fb is the buoyant force. Consider the shape of balloon is spherical, so volume of balloon is 4 by 3 pi r cube. Here radius is 5, so volume of balloon is 523.598 meter cube. Now consider ideal gas equation. PV is equal to say mRT. Take volume into the right hand side, so P is equal to say rho RT and rho is equal to say P by RT. So density of helium is P by RT. So P is equal to say 100 into 10 to the power 3 upon gas constant of helium is 2080 and temperature is 288 Kelvin. So density of helium is 0.1669 kg per meter cube. And density of air is 100 into 10 to the power 3 upon 289 into 288. So density of air is 1.2014 kg per meter cube. F1 is the weight of the helium gas in the balloon. So F1 is equal to say m into g. So mass of helium is 0.1669 and volume is 523.598 and g is 9.81. So F1 is equal to say 857.281 Newton. And Fb is the buoyancy force. So Fb is equal to say m into g. So m here is air. So mass can be written as rho into v. So Fb is equal to say 1.2014 into 523.598 into 9.81. So buoyant force Fb is equal to say 6170.986 Newton. So from free body diagram, F2 is equal to say Fb minus F1. So F2 is equal to say 617.986 minus 857.281. So F2 is equal to say 5313.705 Newton. That's all for GATE previous year. Now comes to ESE previous year. Question first, what is buoyant force? Option A, lateral force acting on submerged body. Option B, resultant hydrostatic force on body due to fluid surrounding it. Option C, resultant force acting on submerged body. Option D, none of this. So correct answer is option D, because when a body is either fully or partially submerged in a fluid, a lift is generated due to the net vertical component of the hydrostatic force it experienced by the body. This lift is called the buoyant force and the phenomena is called buoyancy. Question number 2. Which one of the following is condition for a stable equilibrium for a floating bodies? Option A, the metacentre coincides with center of gravity. Option B, metacentre is below the center of gravity. Option C, the metacentre is above the center of gravity. Option D, the center of buoyancy is below the center of gravity. So correct answer is option C. Question number 3. The resultant pressure of the fluid in case of immersed body act through which one of the following? Option A, center of gravity. Option B, center of pressure. Option C, metacentre. Option D, center of buoyancy. So correct answer is B, center of pressure. Question 4. The metacentric height of a passenger ship is kept lower than that of the naval or cargo ship because option A, apparent weight will increase. Option B, otherwise it will neutral equilibrium. Option C, it will decrease the frequency of rolling. Option D, otherwise it will sink and totally immersed. So correct answer is option C. It will decrease the frequency of the rolling. Question number 5th. Consider the following statement. The metacentric height of a floating body depends. First, directly on the shape of its waterline area. Second, on the volume of liquid displaced by body. Third, on the distance between metacentre and center of gravity. Fourth, on the second moment of waterline area. Which one of these statements are correct? Option A 1 and 2, option B 2 and 3, option C 3 and 4, option D 1 and 4. So correct answer is option B. The stability of a freely floating object is assured of its center of. Option A, buoyancy lies below its center of gravity. Option B, gravity coincides with center of buoyancy. Option C, gravity lies below its metacentre. Option D, buoyancy lies below its metacentre. So correct answer is option C, gravity lies below its metacentre. Now question number 7. Large metacentre height in a vessel. Option A, improve stability and make periodic time to oscillation longer. Impair stability and makes periodic time of the oscillation shorter. Option C, has no effect on stability or the periodic time of oscillation. Option D, improve stability and make the periodic time of oscillation shorter. So correct option is D. Large metacentric height improve the stability and decrease periodic time of the oscillation. Question number 8. What are the forces that influence the problem of fluid static? Option A, gravity and viscous force. Option B, gravity and pressure force. Option C, viscous and surface tension force. Option D, gravity and surface tension forces. So correct answer is option B, gravity and pressure force. That's all for today's lecture. Hope you like the video. Please like, comment, share and subscribe. Hello friend, welcome to